Okay, so this question focuses on trigonometric identities and differentiation. So we're given that y is equal to 3 sine theta over 2 sine theta plus 2 cos theta. Show that when we differentiate it, so dy over d theta, we get a over 1 plus sine 2a, where a is a rational constant that needs to be found. So this is a 5-mark question. So we know from looking at the first identity and the second identity that it's been differentiated. So we know we somehow need to differentiate this first one in order to get the second one. So let's think about what we might use here to differentiate. Well, this is a fraction. We have a top and a bottom. So we're going to have to use the quotient rule to do this. So remember, the quotient rule is dy over dx is v u dash minus u v dash over v squared. Okay. Now on this, we know that u has to be differentiated to get u dash and v has to be differentiated to get v dash. So we also know when we differentiate sine, we get cos, and when we differentiate cos, we get minus sine. So these will be useful identities that will help us for this question. So let u equal the top half, so we get 3 sine theta. So u dash, or du over d theta, is going to give me, differentiate this, 3 cos theta. Okay, now I'm going to do the same for v. So let v equal 2 sine theta, so the bottom half plus 2 cos theta. Now v dash, when I differentiate this, I'm going to get, differentiate sine gives me cos, so 2 cos theta. Differentiate cos gives me minus sine, so minus 2 sine theta. Okay, now to get dy d theta, I'm going to apply my quotient rule over here. So this tells me v, which was 2 sine theta, plus 2 cos theta, multiplied by u dash, which was 3 cos theta, minus u, which is 3 sine theta, bracket, multiplied by v dash, which is 2 cos theta minus 2 sine theta. And that is all over v, which is 2 sine theta plus 2 cos theta, all squared. Okay, so now we have something like this. It's just a simple case of simplifying. So what I'm going to do is I'm going to rub out what we've got here so we can keep the question on the board. And we're going to simplify that statement we just had there. So I'm going to write the statement small over here. So dy d theta 2 sine theta plus 2 cos theta, 3 cos theta minus 3 sine theta, 2 cos theta minus 2 sine theta, all over 2 sine theta plus 2 cos theta squared. Okay, so now let's start by simplifying this. So if I multiply this out, first one, 2 sine theta times 3 cos theta gives me 6 sine theta cos theta. Multiply it with the next one, gives me plus 6 cos theta squared. So I'm going to minus 3 times minus 2 gives me minus 6 sine theta cos theta, and then I've got minus 3 times minus 2 gives me positive 6 sine squared theta, and that is all over multiply this out. When I multiply this out, don't forget it needs to be written as 2 sine theta plus 2 cos theta, all multiplied by 2 sine theta plus 2 cos theta. Okay, so just be careful when you multiply it that you're multiplying the whole bracket, one bracket with the other. So when I multiply that out, I'm going to get 4 sine squared theta plus 4 cos theta sine theta plus 4 cos squared theta plus 4 cos theta sine theta. And you can use any method, FOIL or grid method, or whatever you prefer to do this. So now let's just simplify what we have. So we've got 6 sine theta cos theta minus 6 sine theta cos theta, so that cancels out with that. So we get left with 6, and I'm going to take the 6 out because both of these contain a 6, and you'll see why in a moment. Cos squared theta plus sine squared theta all over 4 cos theta sine theta, and then 4 cos theta sine theta gives me 8 cos theta sine theta, and then again 4 plus sine squared theta, and then 4 plus cos squared theta gives me, I'm going to take the 4 out, 4 cos squared theta plus sine squared theta. Now I know cos squared theta plus sine squared theta is equal to 1, so both of these now are going to be equal to just 1, so they can actually disappear. So we have 6 over 4 plus 8 cos theta sine theta, and we can divide everything by 2 here, so we get 3 over 2 plus 4 cos theta sine theta. Now to get what the question has asked us, we have sine 2 theta. So we need to look at this identity here and think about what gives us sine 2 theta. Well, I know the identity 2 sine theta cos theta is equal to 4 sine 2 theta, sorry. So using that same rule over here, this can be rewritten. So this can be written as 3 over 2 plus 2 sine 2 theta, like that. Okay, so multiplying, obviously this is a 4, this is a 2, so multiplying it by 2 would give me this inequality over here. Now what I can do from here is I can take out the 2, so I have 3 over 2, 1 plus sine 2 theta. Now this is just a constant, a rational constant that needs to be found. So I can see I've got 3 over 2 over 1 plus sine 2 theta. So if I was to just just put the 3 over 2 on the top over 1 plus sine 2 theta, that would be my rational constant is 3 over 2. Okay, so by just simply rewriting what we already have there, we should be able to get an answer. And there we have it.